Across the vast and diverse landscapes of Africa, a silent crisis is unfolding, one that threatens not only the continent's people, but its future. As climate change intensifies, the frequency and severity of floods, drought, and storms grow with it. The continent covers approximately 20% of Earth land area, 60% of the arable land in the continent, and over 1.3 billion mouths to feed. Yet we are still the hungriest continent. Over 500 million people depend on grain-fed agriculture for their livelihoods, which has greatly been impacted by extreme weather events. All the crops, like beans, need water for them to grow. I waited for the rains to start before I planted any of these crops. Water makes plants flourish. I have never received any weather forecast. The only weather forecasting we do is to study the clouds, and when they're dark enough, it means rain is coming. Data drives decision making, and for a climate vulnerable continent, we currently don't have accurate weather forecasts. Weather observations are the foundation on which all forecast products rely, from daily weather forecasts and long-term climate analysis to early warning systems that protect those living on the front lines of the climate crisis. Without these data, national meteorological offices are unable to make skillful predictions of future weather and climate. Forecasting is very data intensive, and with only 1/8 of the minimum density of weather stations recommended by the World Meteorological Organization, we have an opportunity to drive impact. There are not enough publicly available datasets that researchers can use to model forecasting for the continent, and this reduces the effectiveness of global weather models that are widely relied on in the other parts of the world. Better data for better weather forecasts is just a start. As part of the AfriClimate AI community, we are launching a project called AfriNet. We believe a network of community-owned weather stations collecting hourly weather data is the first step towards making accurate weather forecasts available in the hands of every farmer on the continent.
AfriNet AI is a grassroots community founded just a year ago with a mission to harness AI to combat climate change in Africa. Our network includes over 180 researchers, industry experts, and students, all working together across the continent. AfriClimate AI operates on two main pillars: capacity building and AI-driven climate research. Today, we're excited to introduce AfriNet, a project that bridges both of these pillars to empower our community and drive innovation in weather forecasting globally.
So, how are we gonna revolutionize weather forecasting for Africa's future? With our solution deployed around all Africa, the success of our solution in 10 years, precise weather forecasting will drive Africa's resilience and prosperity across key sectors. The impact of our solution as with real-time observation and forecasting, it will empower sectors such as agriculture, water management, and constructions, and many other sectors. It will ensure proactive and informed decision-making. For example, in agriculture, farmers can prepare for changing weather pattern, government can plan infrastructure with real-time forecast, businesses in energy and construction can reduce risk and optimize operation. For example, in constructions, if company would need to cast concrete, they will be able to choose the right time for to have an efficient process of casting concrete. So this will bring also many benefits, such as data accessibility, as reliable real-time data will be available for all sectors. Economic growth also, as minimizing loss through disaster management, maximizing gain in agriculture, construction, energy sectors. Some study consider that investing $1 in weather protection in early warning results, for example, we will have result in at least $3 in socioeconomic benefits. There also is a big impact on sustainability as better water supply, for example, management and efficient use of resources. So our vision for our solution is to create a future where weather is no longer a surprise, but it empowers. So what is our solution? Our solution is really a community-driven weather station network. The cornerstone of our solution is a network building with 100 station weather across the continent owned by our community members, and also the community project, event and challenge that will support this network growth. Based on this network, we will be able then to access to the data to build our knowledge base. And this is the know-how of our solution, where we will work on weather model fine-tuning to get really very accurate weather forecasting, and also we will be able to build a structured and homogeneous real-time and historical weather database across the continent. From this, we will have various possibilities to propose solutions and services for free and paid users. For example, we will have an interactive weather dashboard. This will have a demo just after this, and this is mainly around our community to engage between them and we allow them to have um, uh, to, to use our services. Also, we will propose a free weather API for students and researchers, and this will help to empower them and to give them possibility to advance in their research and also to include Africa in the latest and state-of-the-art research around weather predictions. We will also propose services that can have that can be offered to the farmer authority and many other entities to propose real-time weather alert. This could be through text messages for farmers, for example, WhatsApp messages, or specific detailed app. Here we will adapt our solution to fit with the various user needs that we will find. We can also have more advanced services for companies such as analytics and report, thanks to the accurate data and model that we produced. So what is the positioning of our solution? Currently, we have unique positioning comparing to other similar existing solutions as we have a dual approach where we will work on empowering community and sustaining the growth. So we start from our main objective from which our idea started, which is giving free access and open source data around weather forecasting. Our target here are students, researchers, and local communities. What we want to offer here is free access to the real-time weather's data for educational and research purpose. One of our part of the targets are students in school, teachers in school being part of our community to help by proposing them also educational kits with weather forecasting kits that will help them to access to our community with the objective of enabling informed decision making, promote scientific research, and improve weather literacy. So through the free access, what will happen is that we'll have community building growth and content coverage growth. This growth in both coverage and data volume, it will help us to get a continuous service improvement, which will bring us give us possibility for diversification of provided services. As the more data we have, the more accurate model will be, and the more coverage also we will get, the more paid service will be able to propose. These paid services will target companies, large farmers, and commercial entity, where we will offer them premium services, detailed analytic, hyperlocal forecastings for farmers, for example, and personalized weather reports. This will bring us to give us the revenue stream through subscription-based access for businesses meeting that would like to mitigate risk and improve agriculture productivity. This revenue is very important for the sustainability of our model because through this revenue, this will drive to fund continued development and free community services, which will close here our virtuous cycle of growth that will, and this revenue also will help us to get the sustainability of our free access model.
In this part, we present to you our platform, which is designed to democratize weather data across Africa by building a community-driven network of weather stations. This section allows users to visualize data, monitor trends. It provides users with a personalized experience where they can track their stations, contributions, and stay up to date with the weather patterns in their region. To encourage active participation, we've implemented a leaderboard system where users can see top contributors and to be motivated to contribute more. This sense of community ownership is vital for maintaining accurate and relatable weather data. Our platform isn't just about data collection, it's about fostering a community. Users can engage in discussions, share insights, and collaborate on weather related topics. The collaborative nature of the platform encourages knowledge sharing and continuous learning within the community. Moving to the Live Statics interface that gives users access to real time weather data, including temperature, humidity, and other key metrics. The real time data is essential for farmers, local businesses, and communities in making critical decisions. Through this platform, we aim to create a culture of collaboration and data sharing that benefits everyone.
Weather stations collect data like temperature, humidity, precipitation, wind speed, etc. Stations send data via MQTT or HTTP protocols. Now, IoT Core serves as the entry point for weather stations, and we are using certificates and IoT policies to authorize stations' communications. For stations that send data by HTTP, API gateway receives the request. Lambda functions are triggered whenever data is received through IoT or API gateway, and the weather data is validated and optionally formatted before being sent to the database. Once processed, the data is saved in DynamoDB, our NoSQL database. DynamoDB stores aggregated data for each weather station. It provides fast read and write for real-time data access. Kinesis receives real-time weather data streams for continuous analysis and processing. By the way, S3 stores raw and historical weather data files, ideal for long-term backups. And finally, dashboard and services interacts with the API to visualize data. Here we can see the different steps of an API interaction. It all starts with a request sent, which goes through API gateway and is then processed by a Lambda function. For this example, the Lambda function generates simulated weather data, and finally, the API returns a response with data. Here is an example of a post request we sent to our API to simulate sending weather data from a fictional weather station. As we can see here in Postman, we send a JSON object with values like temperature, humidity, wind speed, and other parameters. After sending the post request, the API returns a response, confirming that the data was received successfully. This message lets us know that the API processed the request correctly, even if this data is dummy for now. Next, we have a GET request that is used to retrieve the simulated weather data. Here in Postman, we are sending a GET request to the API to get the information about a specific station, identified by its station ID. In response, the API returns simulated weather data, as we can see here. This includes current temperature, humidity, wind speed, and other metrics. While the data is randomly generated for this demo, it shows how the API will behave once we receive real data from weather stations.
Here we present our roadmap through 4 phases, and mainly one phase is for proof of concept of our product, then our service proof of concept, and then the growth phase. During next year, we plan to work on proving the concept of our product by testing with 20 to 100 station weather equipment, mainly will be owned by AfriClimate AI member and supported. This will help us to get really quick feedback loop because at this level, we will still have sparse data and we will have limited increase in accuracy at this level. What we want to focus is the quality of data that we get, to validate the station's equipment and any coverage limitations of those stations. And then after validating this, we will start to work on service proof of concept the next 2 years. At this level, we will assure full coverage for at least one country and identify bed service opportunity. At this level, we'll have still sparse data outside of the selected country, but a full coverage in this country where we want to achieve state-of-the-art model for the selected country for the weather predictions. Our growth strategy and user at this level will be more climate enthusiast communities outside of AfriClimate AI, but also we'll try to focus on school with teachers and students, but also kids through educational kits of this station weather equipment version for education. And we hopefully at this level get our first bed users on these selected countries. And then we enter to our growth phase from 2028, where we will start to select countries where we feel there is appetite for our services, and we start our scaling by applying what we did in these 1 country to the 20 countries where we target to replicate the state-of-the-art model for weather prediction in those 20 countries, and of course work on open up our data for research students. At this level, we'll start to get very relevant data. Our growth strategies and users are large bed users, student and research, but also partners with other local community. And then from 2030, we make the full continent scaling by applying all those model to the whole country through the Africa. And at this level, we will start to be more focusing on the quality of our services to get pre-planned and bed targeted station for the area that we have gap, so we can continue to achieve our full coverage of Africa.
We have identified 3 main challenges that we anticipate, especially at the start of the project. First is shipping and policies. We anticipate facing potential delays in delivering stations to their intended locations due to shipping restrictions and local policies. To mitigate this, we'll aim to purchase stations locally or prioritize areas without restrictions. Second is funding limitations. Budget constraints could limit the number of weather stations we can deploy, leading to low coverage. And finally, data quality and maintenance. Once activated, we anticipate challenges in ensuring consistent data quality and proper maintenance of the station. Protecting the station owners and the data collected is a top priority of the data team. Although the weather signals collected are not considered to be personally identifiable information, combined with other data, they might inadvertently reveal sensitive information about the location or activities of the station owners. We will make it a top priority to preserve the privacy of the station owners by protecting sensitive data such as exact location of the weather stations along with other mitigation techniques. Also, data collection will be limited to what is necessary for weather prediction. The data collected will be stored in secure data stores that are compliant with the regulations of each country of operation. Our project is by the people and for the people. We recognize that its success will root from community engagement. That's why it's crucial to maintain and foster the community through building trust and demonstrating impact. We plan to achieve this through prioritizing transparency, explainability, interpretability, and community feedback loops. For transparency, station owners and the public will be informed about how their data is being used, stored, shared, and how it's actually making a difference. Regarding explainability, we're going to be explaining the weather prediction model in a way that enables local shareholders to understand their impact as well as their limitations. Regarding interpretability, we're going to be providing the project outputs in formats that are easily understandable by the stakeholders and via communication channels that are accessible and reliable in their various geographic locations. And finally, we're going to be creating active community feedback loops. We're going to be involving the local community in both the planning and the implementation of the project so that the system is integrated in their existing knowledge and practices. We're going to be building ongoing communication channels so that it's easy for the community to always voice their feedback.
We are blessed with an amazing team. Um, so we have Aya from Egypt, who's our solution architect, Pat Malik from Senegal, who's working on the API development, Sabrina from Algeria, serving as project lead and also our connection to AfriClimate AI, Jacqueline from Kenya, who's our machine learning engineer, Amin from Tunisia, who's our product lead, Samkelo from Eswatini, who's also working on the API development, and finally, Asma from Tunisia, our front-end architect. As we work together to shape a climate-resilient future, we have thought of 4 impactful ways for you to contribute to our mission, because real change happens when a community takes action. First, you could become a station owner and help us collect more weather data. Maybe you know of some funding opportunities, or you could spread the word, or even connect us to local stakeholders like farmers who would benefit from a more accurate weather forecasting. Thank you very much for listening.